Hey, did you know particles are the very thing that hold our universe together? Like electrons, protons, neutrons, the list goes on. But there's this one particle that until now we've actually started learning more about, the neutrino. What is a neutrino though? Think of it like this. A neutrino is a particle with nearly zero mass and no electrical charge, meaning it's basically invisible and nearly impossible to detect. Which is why until 1956 we actually detected the neutrino, thanks to Frederick Rines and Clyde Cowan. But back to neutrinos. Billions of neutrinos are passing through us and we don't even notice. But where did we first get the idea of neutrinos? From the great Wolfgang Pauli, who in 1930 predicted the existence of a particle named the neutrino. But how did he predict it? Through seeing missing energy in beta decay. This then led Frederick Rines and Clyde Cowan 23 years later to detect neutrinos. Since then we have discovered neutrinos actually have flavors and change as they travel through space. But let's take a step back. We've used a bunch of smart physics words without explaining them, so let's do that now. First we have beta decay. There are two types of beta decay, called plus beta decay and minus beta decay, represented by these two equations. Both essentially explain how a neutron or proton transforms into a beta particle in an unstable nucleus transform. Without going too deep into particle physics, this led to Wolfgang to predict the existence of the invisible particle we know today as neutrinos. Next we have neutrino flavors. Neutrino flavors are the three, and theoretical fourth, types of neutrinos. Each are different from each other but are able to change to one another easily. First we have the tau neutrino, then electron neutrino, and the muon neutrino. There is also a theoretical fourth type called the sterile neutrino that only interacts with gravity. But back to the main three. These three main types have a hierarchy because the three main types have a possibility of being heavier than one another, giving us this hierarchy shown here. Also, physicists are still trying to figure out the exact order of the hierarchy since it's very hard to determine the mass of a neutrino flavor. Unless you decide on becoming a particle physicist, you won't need to know about the formulas of neutrino oscillation. But it's basically the way a neutrino changes flavors through space. Congratulations, you now know what a neutrino is, how they change flavors, and what beta decay is. Neutrinos are very weird, but that doesn't mean they are irrelevant. Physicists scratch their heads in confusion trying to decode the neutrino. Thankfully you don't need to worry about that. Thank you for watching. If you liked this video, feel free to subscribe. It would mean a lot to me and give me motivation to keep explaining things in physics in less than 5 minutes.